Hello guys, today we start to study chapter 2, Motion. This chapter contains 14 sections divided into 4 parts. We will learn how to describe motion, acceleration due to gravity, force and motion, about Newton's 3 laws of motion, and gravitation, about Newton's gravitational law. Section 1, Speed. What is the speed? Speed is a scalar quantity to describe how fast an object moves. It can be simply defined as the rate at which an object covers distance, or says speed as distance traveled per unit time. Speed equals distance divided by time. Using v to denote speed, d to denote the distance, and t to denote the time, then we have the speed formula v equals d over t. For example, find the speed for a car to cover 24 km in 0.5 hours. Here, 24 is the distance traveled and 0.5 hours is the time. Then from the speed formula v equal d over t, we have the speed equals 24 divided by 0.5, which is equal to 48 km per hour. All physical quantities can be categorized into 2 types, scalars and vectors. Scalars are quantities that have no directions, such as time, mass, speed, distance, etc. Vectors are quantities that have directions, such as displacement, velocity, acceleration, force, etc. We will details about these vectors in later sections. In general, a vector can be represented as an arrow or a letter with an arrowhead. Adding 2 vectors A and B, we can find the resulting vector C by following the triangle rule. Connecting the head of vector A with the tail of vector B, we obtain vector C by drawing an arrow from the tail of vector A to the head of vector B. This is the triangle rule. For a right triangle, the Pythagorean theorem tells us that a squared plus b squared equals c squared. Therefore, considering 2 vectors perpendicular to each other, we can find the magnitude of their addition by using the Pythagorean theorem. For example, use the Pythagorean theorem to find the displacement or change of position of a car that goes north for 5 km and then east for 3 km. According to the Pythagorean theorem, C equals the square root of a squared plus b squared. Substituting a as 5 and b as 3, then we find the displacement C as 5.83 km. The direction of the displacement can be represented by the angle theta between vectors C and A. Tangent theta equals b over a equals 0.6. which leads to the theta to be 37 degrees. Section 3. Acceleration. What is the acceleration? Acceleration is a quantity that describes how fast an object changes its speed. It can be simply defined as the rate of change in speed, i.e., speed change per unit time. Acceleration equals speed change v2 minus v1 divided by time t. This is the acceleration formula. For example, a car accelerates from 15 meters per second to 25 meters per second in 20 seconds. Find the acceleration of the car. From the acceleration formula, we have the acceleration of a car equals final speed v2 minus initial speed v1 divided by the time t, substituting 25 meters per second at the final speed and 15 meters per second at the initial speed and 20 seconds as the time. We obtain the acceleration equal to 0.5 meters per second squared. The acceleration formula can be simply reformed as the final speed formula. v2 equal to initial speed v1 plus acceleration a times time t. So this is the final speed formula. It is derived from the acceleration formula. Just to reform the formula. Same formula. Let's do another example. A car whose brakes can produce an acceleration of negative 6 meters per second squared. Negative means deceleration. Is traveling at 30 meters per second when its brakes are applied. Question A. What is the car speed 2 seconds later? Question B. What is the total time needed for the car to stop? First, from the final speed formula, we have v2 equal v1 plus 80, substituting 30 meters per second at the initial speed, v1. Okay. Negative 6 meters per second squared as the acceleration, and 2 seconds at the time. We can find the speed of the car as 18 meters per second after it travels 2 seconds. For the second question, the final speed is 0 because it stops. Then time needed for the car to stop is what we need to find. The final speed formula can be simply reformed as t equals v2 minus v1 divided by a, substituting 0 as the final speed, v2, and 30 as the initial speed, v1, and negative 6 meters per second squared at the acceleration. We obtain the time needed for the car to stop to be 5 seconds. Section 4. Displacement, time, and acceleration. Dividing the sum of initial and final speeds by 2, we have the average speed. Multiplying the time to the average speed, we have the distance traveled in the time. Replacing the average speed by v1 plus v2 divided by 2. Replacing v2 by v1 plus at and simplify it, we obtain the distance traveled as d equal v1t plus half at squared. This is a very important distance formula. The final speed and the distance formula are two fundamental formulas for the constant acceleration motion. For the example we did about what is distance traveled 2 seconds later, and what is the distance traveled before the car stops. From the distance formula, substituting 2 seconds at the time, we find the distance traveled 2 seconds later to be 48 meters. Substituting 5 seconds at the time, we obtain the 5 seconds before. We can find the distance traveled before the car stops to be 75 meters. Using the final speed formula to eliminate the time t from the distance formula, we can express the distance by another formula, v2 squared minus v1 squared divided by 2a. This formula, distance formula, is not new formula. It's derived from the final speed and the distance formulas, just eliminating the t, the time. For constant acceleration motion, if time is not given, then we can use this distance formula to directly find the distance. Section 5, free fall. Free fall is a spatial one-dimensional motion. Its initial speed is 0 and the acceleration is a constant. When you drop a stone, it falls. Galileo free fall experiments conducted at the Leaning Tower of Pisa indicated that the higher a stone is dropped, the greater its speed is when it reaches the ground. This implies the stone accelerates due to the Earth's gravity. He further obtained that the acceleration is the same or constant for all stones, big or small. The constant acceleration due to Earth's gravity is called gravitational acceleration, and its value is measured equal to 9.8 meters per second squared. So free fall is a one-dimensional spatial motion with 0 initial speed and a constant acceleration that equals 9.8 meters per second squared. In general, after falling time t, the speed of falling object is v equal gt, and the distance failed is h equal half gt squared. A free fall object does not have an initial speed. For a thrown object, the initial speed is not 0. The throwing direction can be various, such as horizontally, upward, obliquely, and so on. Projectile motion is a typical two-dimensional motion of a thrown object. We don't go to detail about the formula of this two-dimensional motion. Next section, L resistance. L can exert a force on a moving object in the opposite direction of motion. This force is called L resistance.